here we go.
To locally.
Did it work?
Okay.
Can you guys hear recording in progress?
Yes.
Okay.
Yes.
All right, very good.
Okay, great.
Okay.
I will.
Yeah, I heard
I will
it. Yes.
check out it later.
Mhm.
I
Okay.
have to have an appointment. Unfortunately, I have to go. You guys can keep talking. I will follow up when I get back. Okay.
All right.
All right.
All right.
Happy holiday
Good to see you,
again. I will see you. Okay.
We'll see you
Good to
soon.
see you, everyone here. Just keep
All right,
the
see
good
ya.
content going, man.
Mhm.
Very good. Okay. I will listen later. Okay.
Mm. Yeah. So I think.
But,
that, go ahead, Kevin.
Yeah, I think because I'm not super technical and I didn't understand a lot of what was discussed in this, but I do understand having a protocol that's well incentivized so that we don't get burned. Because I got burned by a protocol that collapsed, you know,
Right.
and that's like the worst. But and one of the things I've been trying to understand with what Craig is talking about with decentralized and all this, what he means is that it's you issue a protocol, like somebody issues a commodity, and then you have all these economic actors that are working to fulfill it. And that's a pretty cool idea.
Yeah. So, I mean, with regards to like the architectural problems with getting these transactions in the right order and making sure that my answers are correct, I mean, I have certain things that I do on my end, right? And I'm very confident that that any bridge that I commit to hosting on my Bridgeport node, which you can actually use, you can actually create bridges that run on my Bridgeport node for free at the moment. I will make it cost money later when I build a building system, but I don't like building systems. I like building Bridgeport stuff and other cool things. Let's see, any bridge that you write that runs on my Bridgeport node will have the transactions in the correct order because of I mean, I guess not only the economic reasons, but because if I were somehow to not have it in the correct order, then somebody who does have it in the correct order would be able to prove that I was lying, and it would be a very big I guess risk for me to do that. So anybody can build a Bridgeport node that hosts things. And then the other, I guess I'll share my screen again just to show this, but I've got the Bridgeport host resolution protocol, and that's just the mapping that basically says, so BHRP basically says here, what did I do? I need to go back to my other window. Bridgeport host resolution protocol is the thing that allows a Bridgeport node to advertise that they host a specific bridge. So this is where we have the Bridgeport node having its own private key. And these are the design considerations of the Bridgeport or the goals section, right? So we have permissionless, any Bridgeport node, anyone should be able to advertise they host any bridge at any URL at any time and for any duration. So if you lie, everybody ignores you because you literally have to broadcast out that you're hosting a specific bridge at any at your particular URL. And if somebody goes and checks that out and it's not correct, well then why would I even add you as a potentially trusted bridge in for example, Parapet. Parapet is a library that compares the results from various trusted Bridgeport nodes and sees which ones are fairly accurate. By comparing, well, I trust this guy with 3 trust points and I trust this guy with 2 trust points, right? And the one with 3 is probably going to be authoritative if they disagree. But usually, I guess if there's a tie, then you just pick the first one. And maybe you have a confidence indicator that's very, you can return a confidence indicator as well. Like, well, I'm very confident that this is the correct result because 10 different Bridgeport nodes said so. But if 5 of them disagree and 5 of them are one way, 5 of them are the other way, and you return a very low confidence indicator, and usually you'll have software that's programmed to basically, not, it would throw an error or give a very, very severe warning if something crazy like that were ever to happen. But I really think there's strong economic incentives to prevent that from happening. So, I mean, I guess, not only the economic reasons, but because of Yeah, so each Bridgeport node basically builds its reputation, and that's what Bridgeport Host Resolution Protocol is. It's DOS resistant because hosts that don't have a good reputation shouldn't be able to disrupt the system, and they can't because of the way this is designed. They're just going to be ignored. And we've got tamper resistant, so obviously just anyone should be able to verify that a host is providing invalid data by hosting the bridge themselves, and friendly to new hosts, right? So should be able to it should be possible for new hosts to build a good reputation by hosting bridges that no one else has. So that's interesting. If I'm a new Bridgeport node and there's like some niche thing that I want to do that nobody else has really done yet, I can be the only one with this particular window into the blockchain. And so if there's high demand for this window into the blockchain, and I'm the only one that can do it, then I can get some reputation. And then eventually other people are going to come on board because they're like, well, I want to have this, I want to make this available too, and I want to make sure this guy isn't lying. I mean, there's a strong incentive. If I'm the only node that's running something, other people are going to want to, people want distribution. They want a distributed sort of guarantee. Like if there's only one miner on the blockchain is less valuable. When there's 10 miners, the blockchain is more valuable because there's multiple miners, and so there's less of a chance of any malicious attacks or anything like that, I guess. So for that same reason, I mean, it literally takes the same incentives that make Bitcoin work for the past, however many years, and it brings them to the higher level by allowing people to derive state from the blockchain in a deterministic way. And it's deterministic because of the bridge ID being associated with a specific and very concise set of criteria for what it means to host this particular thing. Just like the consensus rules of Bitcoin are very specific and concise, because if they weren't, if the consensus rules of Bitcoin were, well, we will accept blocks that are between, we're going to stop accepting blocks that are around 1 megabyte, right? Like the core guys, they could say, well, our block size is around 1 megabyte, but we're not going to say exactly what it is. That obviously wouldn't work, and the network would completely fragment. So the point is that consensus rules need to be very concise, and that's what Bridgeport does. Is it makes it so that you define the rules and then you follow them, and then if you don't follow them, you definitely didn't follow them, and somebody has a way of proving that. So just some economics as well as some technology there to hopefully make that work. And we'll see if it works. I don't know. It might not. Who knows?
Cool. Well, I don't know if that helps David's issue or not, but I learned a lot about Bridgeport because a lot of the stuff I didn't understand, but now I got the full education. I think that's a cool. The coolest idea that I think is being able to have just economic incentives to maintain some sort of, base layer of your app instead of just relying upon, like I used to rely upon Facebook just to maintain this thing on their server. But if I could have it distributed where there's all these economic actors, oh my gosh, that'd be so much better. So
there is no more servers. I mean, literally anything, if you derive your data from the chain, or if you put your data on the chain, like even if it's derived from a third party or somewhere else, right? Like you get your IoT sensors, but you put those sensor data on the chain. You can write a bridge that defines how that data is to be interpreted and made available over time. And then you can use Parapet, which I had pulled up before, to just talk to that bridge. You're not even talking to a Bridgeport node specifically. You're not even talking to a server anymore. You're just talking to whatever Bridgeport node ID you have, right? So in this case here, I'm talking to the Hello World Protocol bridge. And that's, I make a query against the database associated with this ID. And I'm no longer relying on, so whoever is able to competently host that advertises such. And then I have a list of trusted hosts that that have built their reputation in my eyes over time. And those are the ones who we talk to. And so we can derive, you could host the entire blockchain inside of one Bridgeport bridge. If somebody wanted to write a very basic protocol that says, take all transactions, store all data, and then make all data available, there would be a global bridge, which would be very, very expensive to host. But if there's a reason to do that, I don't think there will be. But if there is, I'll let the market decide on that one. Maybe somebody has a really strong reason for hosting every single piece of data ever put on the blockchain for all of eternity. But I have a feeling they're going to specialize because that's what people do. I mean, that's a very wide-ranging thing, but I think that people specialize to do a lot of things. So I guess one of the things I could show is the dashboard. So here we can see, this is my dashboard. So I can use this to, like, here's all the repos on GitHub that run my bridges. And this is just my way of building a Bridgeport dashboard for my Bridgeport node. It's not, somebody else, of course, when they build their own Bridgeport node to host bridges, they're going to use a different, this is just if you want to host a Bridgeport bridge on my Bridgeport node, then you can read this documentation, you can write your code in this particular way, and you can use this to open a new. So you just provide your repo URL, you install the Bridgeport GitHub app into your repo so it like connects up with your code base, and then you just you generate a bridge ID, you sign an authorization that says, I hereby authorize Ty's Bridgeport node to host my bridge, and that gets signed with the bridge private key. So that way I have a, that way they've allowed me to host it. And then you deploy your bridge by writing commits to your GitHub repo, and my Bridgeport node will look for those commits using its GitHub app, and it will then automatically deploy when it gets a new commit in that repo, and it'll spin up the MongoDB database, create the users, allow you to pull in the transactions, and then I will just send all of the transactions into the code base that you write, and all of them will be sent in the right order. There is a condition for rollbacks where you just write an on rollback thing that says, so you have on process forward and on process backward that allow you to take the data and insert it into the database the way you need, or in the case that the transaction needs to be rolled back, remove it out of the database and bring the database to the state where it was before that transaction got processed. And then it's on me to send you the transactions in the right order. And like I said, I have a very, very strong reason to make sure that that bridge gets those transactions in the right order. And other people are going to write Bridgeport nodes that do the same thing. So these are all of my bridges. So for example, and this takes a little while to load just because this is pre-alpha software. All of this is pre-alpha. But if I click into the, I don't know, I'll go into the sCryptStudio bridge, I guess. Wait, is that, it's this one here, sCryptStudio. So I can see the two deployments that I have, and one of them's published. So I made my initial commit, and I can see that it was committed on this time, and here's my deployment log. And then here's the new one, commit hash on GitHub, and then we can see it getting pushed out to my Bridgeport node, right? So there's that, and then using that bridge, I've created an sCryptStudio. So this is going to allow a person to, write sCrypt smart contracts. I've just clicked on this contract here, and again, it takes a little while to load, but there it is. Very, very advanced contract right here. This is state-of-the-art, latest sCrypt features. And you can deploy it on chain. You can track the UTXOs. This isn't completely finished yet. In fact, I would say this is about 20% of the way finished. You can save changes to the file. I do have that working. So if I made a change here, you can see this button kind of opened up. And then if I undo that, now it's saying that the latest changes have already been saved. You you can publish the code to a public registry so that you can see everybody else's, and this isn't functioning yet, but eventually people will be able to write a title and description for their contract code and then publish it to a public registry where anybody can see the contracts that have been published, and using those contracts, you'll be able to, adapt them to whatever you want to do. So somebody could make a contract for, I don't know, shares of a company or whatever, and that would show up in this list here on the left. There will be a search bar when this is implemented, and then yeah, I'll be able to save a copy of the published registry code as a private file. So all of my files, this is a Babbage desktop app, so all of my files are not like public. Like I write a code, I write some code in this here, and it's not like it's encrypted using keys that only I have, because in Babbage desktop, if I go here, this is me and these are my keys and nobody else has these keys. So I take an action that says, well, let's see, save changes to test.sCrypt. Yes, exactly. So I save changes to this file, and that's how I have my thing inside sCryptStudio. So here's my permissions. Whoops. We can see that sCryptStudio has permissions to do certain actions, and we can see that the actions that have been taken here are, first I allowed it permission, I granted whatever, so my contracts that I'm working on are private. Nobody can see them because they're encrypted. I publish to the registry. People can see them, obviously, it's public and it's in the public registry. And so yeah, public code registry here. And this again is not implemented yet. And then I can also, because of the new feature that I built in Babbage Desktop recently, I can deploy a contract onto the chain, and then I can see the actual UTXO, and then I can update that UTXO. So if it's like a STAS token thing, I can spend it forward to its next state, and I can see what the next state is. And I can pass in the parameters to the public function that I want to use to redeem the contract and use it to, spend itself forward, right? And then submit that. And all of that is tracked using Bridgeport. So this application runs completely on chain. All of the state of this application, including those two files that I had in my my contract here, are tracked using Bridgeport. So I have an sCryptStudio bridge. And so here's the protocol. So we can see op return, and then you use op return, and then you use, here's the protocol namespace, and you have different protocol verbs that you can use for things like storing a local file that's encrypted. So the data is encrypted, so no one's going to be able to see it. It's on chain, but it is encrypted, or it's protected by keys. And so that's one thing. And then there's going to be I did write the protocol for the public registry, but I never implemented it yet because I started building this a couple of days ago, and it was Thanksgiving and stuff. So I wanted to have it finished, but I didn't. So that's how you build an application and derive its state from Bridgeport. And so if Kevin ran a Bridgeport bridge that hosted the same sCryptStudio protocol, if my Bridgeport bridge crashed and Kevin's kept running, this application would just keep running. It doesn't even care, because it's going to use the data that's available. It's going to use the data that's advertised by the people that host particular Bridgeport bridges. So that's kind of how that works. And I guess that's kind of my little demo of what I built to demonstrate Bridgeport and also UTXO tracking, but not fully yet. It's very early days with all of this stuff, but yeah, that's kind of what I ended up building.
Well, Babbage versus Bridgeport, yeah, I'm not clear on two different names.
Okay.
Babbage is the IDE you built, maybe? Is it
No.
fundamental
So
IDE?
So Bridgeport is the thing I've been talking about this whole time. Babbage is not really relevant. It's just a way of creating transactions. Think of it like a money button wallet or something that just sits in the background on your computer, right? So this is a different app that I built for key management and stuff, but that's not even relevant. If you have a way of creating Bitcoin transactions that don't use Babbage, you'll still be able to put those Bitcoin transactions on Bridgeport. So, you know, I have a library called Bridgecast. If I go to Bridgecast, this is a library that basically says, you know, here is my transaction, and here's the bridges that I want to notify about that transaction. And wherever you got that transaction from, it can just be sent to Bridgeport. It doesn't have to come from Babbage Desktop. Babbage Desktop actually uses Bridgecast internally to let bridges know about transactions, and they can be tagged, but they don't have to be. It's just more economically efficient, and also it's easier technically if they're tagged, but they don't have to be. Babbage Desktop is separate from Bridgeport. I mean, I can take, you know, you can build Babbage apps that create transactions using Babbage Desktop, or eventually Babbage Mobile. And I guess I'm on the record for saying that I'm going to do mobile now. But
It's all JavaScript.
All of this is JavaScript.
Using JavaScript like sCrypt. Yeah, it's all JavaScript, right? Okay.
I mean, you can use any language, I guess, to build any of this stuff, but I like JavaScript. I mean, you don't, if you want to run a Bridgeport bridge on my Bridgeport node, then as of right now, you should use JavaScript, because that's the only runner that I have. But if I had more
so
people,
it's Node.js underneath?
Oh, underneath, yeah. So yeah, it runs
Node.js.
Yeah, it runs Node.js. Well,
all right,
runs on like a scalable, what's it called, Cloud Functions. Google Cloud Functions is what runs my Bridgeport bridge. But again, the point is that, like, yes, I'm using Google Cloud, right? But other people can use other things, and it doesn't really matter what they use. They could have their own in-house, you know, data center inside of a bunker or something, and just get the right answer. That's kind of the point, right? Like, I mean, my favorite math teacher did not tell me, oh, you got to show all your work. She just said, just get the right answer. Most of them said I have to show the work, but the point is, like, if you're running something, however you're doing it, I mean, I could be very kind of contrarian or something. I could say something like, well, it's none of your business how my thing works. But, you know, I'll share that, yeah, it runs on the one architecture and whatever else. But the point is, you know, I do what I need to do to get access to the data, and anybody can use, you know, if someone wants to use COBOL or whatever else, they can do that. If there is a Bridgeport node that will run a bridge that is written in COBOL, first off, I'm sorry, but secondly, good on them, because they can still compete and they can still keep running their COBOL. It's not going to be me. I mean, I don't explicitly exclude that possibility, but in all reality, it's not going to be me that makes COBOL run, but somebody could. And the protocol is language agnostic. Like, none of this stuff has to be JavaScript. It just, I happen to have written, what's the number up to now? If I go here, I happen to have written 93 repositories full of JavaScript. So I guess that makes it my language of choice. But yeah, different technologies that work in different ways. So if someone else creates a Bridgeport bridge and competes with me and provides better service, then my Bridgeport bridge will go out of business, unless I'm cheaper or something. I don't know. Markets do that stuff.
Well, does it depend on Mappy right now, or
internally for my thing? I use a couple of things. I use BitSocket and Bitbus from Unwriter, but I also have plans for you know, talking with other miners, and I don't want to get into, you know, because it's a public forum, but I'm talking to some other people about doing some arrangements for my needs, you know, for my thing. But someone else could build it however they want, as long as they get the right answer for the queries that come in. You could do it with Mappy. You could do it by running your own Bitcoin node. And, you know, for people that want to run a Bitcoin node just because they think it's cool, I mean, they could make some money doing it by, you know, I could go to, I don't know, I could go to like Slictionary or some app, just some random app I could think of, or Duro Dogs or whatever, right? And I could say, for this price, I will host all of your data, make all of your servers irrelevant, and make everything completely deterministic run on top of Bitcoin, using the very, you know, using the robust nature of Bridgeport. And I could take money from these people to host their services. So if you do that, then you get their business, and if I do that, then I get their business. And they write their protocol and publish it, or they have their particular bridge ID address, and it's very clear which of the people involved is providing the correct information at the correct time. And however they get that correct information, maybe they have custom arrangements with particular miners that make sure that they always know what they need to know. But again, if those arrangements aren't good enough, then they obviously suffer economically because they can't provide the correct information. So I see that as how the blockchain scales in terms of all these applications that get built on top. Is I didn't define a particular technology. I didn't define a particular set of set of tools or APIs that I host, and it's on my central thing. What I did is define a framework, really an economic framework, by which those services are incentivized to be created. And using those incentives, I think it works out pretty well, but we'll see if people run Bridgeport nodes, and we'll see if I can make this reliable enough to where I feel comfortable going to these other applications and offering to host their data. That's what I'm working on right now, is just making my technology work in this way that I've defined, because I set out the problem, believe me. I mean, now it's out there, right? The particular task that my server needs to perform is now very well defined. And so I've got to make it work. But if I don't, somebody else can, and they'll take all my business. And that's kind of the way I think it should be. So I don't know if there's much else. There's much else here. I mean, we've only gone for like an hour and a half, but I think there's, you know, some people have kind of dropped off because it's we're all kind of running around to different places.
I think that we should,
Thank-
I'm going to look into, we should not allow our transactions that we're doing, say for Bridgeport apps, to go into those blocks beyond a certain size. And if it goes there, if it does go to one of those, we could say, no, it's not valid. We're going to send it again till we get it mined in a smaller block. And over time, maybe we could figure that we could just have some system like an sCrypt that it detects that it doesn't allow the locking script won't allow it to go in a unreasonably large block.
Interesting. I mean, as the person who creates the transaction, I might not really, you know, I might be indifferent to that, but as somebody who runs infrastructure, I mean, I guess the thing is, like, if I'm running a server with 1 terabyte of RAM so that I can process these ginormous blocks, and I'm making, I don't know, $50,000 a day to do that, and then somebody wants to do more transactions that I need to process. Now I'm making $60,000 a day, but my server is not good enough, so I've got to upgrade my server. So I don't know how those economics work, but I mean,
No, but it looks like the actual, I think they told us at the conference in New York that actually there's bugs or limits in the, we call it Bitcoin D.
Right.
Daemon has limits in it that it just chokes on some.
Mhm.
That's why I've got looking at it real time right now, because I see I had all the way up the last few days, it's been growing and sinking. And then just this morning, it got to that 705,000 point. It's actually
Right.
715,000 right now. Actually need this. Only got, and it just stopped. And I looked at that block and it was huge. So, but that's like what they've done is they've gone too far beyond current average technology. It shouldn't be doing that at this point. That might be years from now. We do 1.8 gigabyte block. Like, I don't know why they ever, I mean, it's just sad because the blockchain is permanently recorded and they can't go back on that.
Right.
We'd have to say, okay, my transaction went into that block. Oh, big surprise, the darn thing's bigger than my appetite. And I'm going to say, no, I'm going to have to send that thing again, that transaction, and demand to go in a more reasonable block. Like, they've messed up the blockchain in my, messed it up.
If you send your transaction to a miner, right? And they say they're going to let you know about the Merkle proof, because really what you want when your transaction is in a block, you want to know the Merkle proof, right? For the
Not
transaction.
necessarily. I want to rebuild. It's a financial system. Anything can happen. Any catastrophe can happen. I don't want to put my money into some system where it can't recover properly in a timely way from God knows what, from scratch, which is just the blockchain. So the blockchain, you can't even read it right now. It just, the node doesn't let you go read that block. You cannot read it. Only the miners have it. They've got it in their memory. The miners keep track of it, I guess, on their hardware. They wrote the block, so they've got a record of it. We cannot read it. It doesn't matter what memory you have. I've got 64 gigs of a gaming laptop. I've got a high-end gaming laptop, 64 gigs of RAM. So I could easily get a 1 gig or 2 gigabyte block in RAM. But the Bitcoin D, for some reason, that it just chokes. I don't know what the bug is. Maybe I could debug it. But they warned us. They said the thing, don't even try to say, yeah, we know it goes nuts after a while. It's doing weird things at that high block set. They say you got to forget using a node, don't use it anymore. And use Mappy. I guess the only thing we have is Mappy to get it. I guess you have to go to transaction for transaction to ask it for it.
Right. I mean, you got different people who are going to end up when this is deployed and whatnot. There's going to be different people.
It'll be in Google. It'll be in Google Cloud in Mongo.
Right.
The record.
In my
case, ask Bridgeport to get it from Google. Your case, yeah. I mean, some might have it. AWS, some people, whatever, how they implement it.
Right. And so if
one of them
fails, I don't see all of them failing at the same time. Is kind of the idea. I don't see all the miners crashing their nodes at the exact same time, just like I don't see all the Bridgeport nodes, crashing at the same time. And so the data is always going to be somewhere. Somebody's going to have it, I imagine. I don't know if that's true, but there would be a very strong incentive that it is somewhere, right? I mean, like, because the alternative, like what we have right now with Facebook, they had an outage during the CoinGeek conference, actually. I thought it was kind of funny because they were the only ones to have it. They were the only ones to have any of the data that they wanted. But if this was run on Bridgeport, maybe there would have been 3 people. And if they would have went down, somebody else would have it a different way. And they would have different infrastructure. And it would have still been available. And everybody would have been able to still send their memes and whatever else on Facebook. And so, I guess there's more memes in that case, but.
Sorry, I just wanted to ask a question. So, what kind of data is this platform going to be hosting? Or is this like is this like taking away the overhead from the miner so that there is a layer in between that provides some of these data versus having to go through the miners itself? Or what exactly, what kind of data are you hosting, or the Bridgeport is going to be porting to?
What happens is when you want to write a Bridgeport bridge for your application, you have a container of sorts, or you have a function, and that function takes as input a Bitcoin transaction, right?
Yep.
And given that Bitcoin transaction as input, it will then write some data into a MongoDB. So you get to parse the Bitcoin transaction however you want to parse it, and then you get
Got
to
it.
insert it into a MongoDB database however you want. So
Mhm.
you define, and then you also define which Bitcoin transactions you want to be passed into your function, you know, which ones you care about and which
Yep.
ones you don't care about. And then
Mhm.
based on the content of your MongoDB database at that particular moment in time when that transaction was created, you can do certain other things, such as, well, that transaction did something which it wasn't allowed to at the current time, according to my protocol, so I throw an error. And so that code that runs those operations is then distributed across all the different Bridgeport nodes. And so each person runs that function by processing the right transactions through it, however they want to go about doing that. So using Mappy or using whatever other tools to get the transaction data. But the data that goes in is a Bitcoin transaction, and the data that comes out is whatever system you want to create on top of Bitcoin.
Okay, got it. So basically like an app. So if I have some like say an app like even Facebook app, and I go through the Bridgeport like run a function that basically has some sort of code, and it basically creates a transaction, and you can separate out maybe the data and put it into a MongoDB, and basically there is a hash, and that hash is probably broadcasted to the miners so that the miners know that at this point this data was published to the MongoDB, and that data is coming out from the app, and making sure that it's like an attestation kind of thing. So for attestation of any data that's coming out from my app in the form of Bitcoin transaction up to the miners.
So
Is that
all the data for your whole app that happened for the last 100 blocks, for example, when that 100th block is created, now it's locked in, unless there's a reorg or something. But a reorg wouldn't there would be other considerations there. So we'll just use the simple case for now. But there are ways of dealing with it. So when that 100th block gets locked in, suddenly all that data that was in those last 100 blocks is finalized, and nobody can change it. So now we can take a hash of that last 100 blocks of data from your particular application and make that public, and everybody knows. So everybody who runs that Bridgeport bridge will do the same thing at the same time and broadcast out. At this time, this was what the database was. And then anybody who wants to later pull down that data to get a copy of your current application state will be able to check the hash when they get that data from a Bridgeport node and make sure the hash is the same, and then continue processing from there.
Got it. Okay.
So they just respin it back up. They don't have to go back and run every single previous transaction through. They just get the current state from the hash, and then that's the current state of the system, and then they run the new transactions through. Maybe because it was 100 blocks ago, there's some very few recent transactions, or relatively few recent transactions, which need to be sent through to bring it back up to speed. But I think that'll be handled by Bridgeport nodes fairly easily. They'll just send the transactions to one another as they do to notify everybody. Because if there's 3 people that run a Facebook bridge, and one of them gets a new transaction, that one bridge is going to have a very strong incentive to let the other 2 bridges know about that transaction. And the reason why is because they want those 2 bridges to stay in sync. So I'm going to let everybody know about the things that I have, because I want them to have the same things I do, so that I'm in sync with them. And
so Bridgeport is more like a function in between that basically provides that, or does it also store data? So when you say MongoDB, is it part of the Bridgeport the platform?
Each bridge is going to perform database operations in a particular way. Like some bridges are going to be incompatible with some Bridgeport nodes in the future, because maybe my Bridgeport node is built around JavaScript and MongoDB, but maybe somebody else builds another one that works with Python and Neo4j. And so you still have the same deterministic, derivation of state from the chain, but it's just done in a different manner. What Bridgeport really is at the end of the day is just an economic incentives framework that keeps people in sync about what has happened on the network in various ways, in various contexts or various windows into the state of for example, a financial system or anything like that. Because multiple actors derive the state from the chain, and the blockchain only has one order. It's not like there's an ambiguity about the ordering of transactions in the blockchain. Everybody knows the correct order. So they're always going to be in agreement about what happens, because they're always going to derive the state of the system from the correct ordering of transactions and from the rules of the protocol that was written. And that protocol can be updated. In fact, and this is something that's a bit more complex. So I guess if people don't fully understand Bridgeport at this point, then perhaps it might be well to ignore it. But you can write a Bridgeport protocol that changes its protocol rules based on future transactions. So you can say that here's my protocol and what it is now, but a rule of this protocol, and this turns into like a security type thing. So we were talking earlier, and Kevin was saying, well, it's fixed if it's, if nobody can change it, but you could put as a rule of your protocol, if you wanted to, that future transactions could update the rules of the protocol by XYZ means, and do that as well. So it's really, really open-ended, and it's really language agnostic at the end of the day. It's just about queries, responses to queries, and pulling transactions, deriving state, running things in the correct order. And that's a challenge. Like, that's a really big challenge. I had to do a lot of work to, when a new block comes in, I've got to roll back the unconfirmed transactions, and then I've got to roll forward the transactions in the block. And then I've got to roll forward the rest of the unconfirmed transactions that didn't just get confirmed. And then I've got to do all of that inside of one single atomic MongoDB transaction that commits. And that way it flips over to the new block without having an interruption of time where we have old data. And that was a challenge. And that's some proprietary code that I probably don't want to share too widely with other people, because I worked pretty hard on it. But it works, and I have the right answers to the queries. And so I have a way of getting those right answers, however it was. And other people can also get the right answers. And if I get the wrong answers and they get the right answers, they have proof that I didn't, I didn't derive my state properly. So it works really well, I think, for that reason, just in terms of the incentives. But it's very early stage software as well. Like, I'm only one person working on this, and there's going to be others in the future. But I think for now, getting this much out there about the descriptions for how it works, the Bridgeport host resolution protocol that allows various bridges to be advertised by a particular Bridgeport node, and then the reputation that goes along with that, and the verification of who's hosting what, and make sure they're not lying and all of that stuff. Those are kind of the core concepts that run the system, and from that you can bootstrap up and bring in more nodes and bring in more complex protocols, and derive any, you're literally any finite state machine that you can think to create, any single system that you can create by deriving state from the blockchain, or putting state into the blockchain, you can do. And so you're as free as you are with what you can do on the internet, only more so because you have all the value stuff that Bitcoin provides with tokens and everything. Pardon me, tokens and everything else. Only now you can do it on, sort of you have all of those same freedoms to basically, it's very, very, very open-ended, and that's purposeful because I don't want to be the one to define what people do. I mean, I created a tool that everybody else can use to create whatever it is they're trying to create. And so I think that's a big part of this also is we've got tools that people can use to do their thing and to write their, create what is they're trying to create. And it can be derived in from chain, just put things on chain, put hashes on chain, put whatever on chain, and derive your state from that, and you get all these massive benefits. And so I think that's kind of the point. Those are the main points, and we'll see what people build on top of that. I think I have an idea. I want to build an on-chain operating system, and I started work on that. I think that's going to be fun because that means that we can have a single device that is abstract and not tied to any physical device. But those are only my ideas. That's not what other people want to do. So I do what I want to do, and they do what they want to do, and we'll see if that gets us anywhere.
I think I like the idea of the operating system because I had some similar imagination regarding, like having an abstract operating system that can work on pretty much any kind of device. You just as long as you have your what do you call
You need the keys to unlock it.
Yeah, just
Your auth factors.
yeah, exactly. So yeah, I think we talked about this.
Yeah.
One of our meetings or one of our meetups last time when you like go to a restaurant and you just you be able to take all your data and go to a different one and something like that. I think that
well, you go to the restaurant and you put your phone on the table, and then you accidentally pick up somebody else's phone, and they accidentally pick up your phone, and you both leave the restaurant, and you're like, oh, I guess I got the wrong phone. Well, it doesn't matter because all my stuff is still here.
Yep.
You just accidentally, you both have an iPhone 11 or whatever same device, and nobody really cares. Devices remain
I would
the
love to
same.
have a conversation on that in detail, like exactly how it's gonna work.
Well, I
and
wrote
so
a
forth, but
paper.
yeah.
It's on
you did?
openstandards.cache.
Oh, okay.
And
Do you mind sending a link to that? So actually, you know what? I'll
I think I've linked it a couple times in the meetup, but if you go
Okay.
to openstandards.cache, or sorry, in the Slack, then I have two papers. One is called Computing with Integrity, which is the distributed operating system and that functionality there. And then the other one I wrote is called Project Sigma, which is once we have devices that run in an abstract way with a distributed operating system, we can create a purely peer-to-peer mesh that eliminates all single points of failure that come from routers and everything else, so that every device communicates directly with, it has the ability on a protocol level to communicate with other devices. So you could think of it as a standard protocol for, I don't know, you remember you go to like an airport and you go on the Wi-Fi and you have to log into their thing and enter your credit card to pay for the network. And then you've bought your internet access for that day, right? Something like that. But imagine that only in a completely standardized way. So it just automatically pays, and now you're paying like per kilobyte of traffic, and you can use any Wi-Fi hotspot because they all follow the same standard. And devices can offer, like how you have mobile hotspot right now, where you got your phone and you can turn on the mobile hotspot, and suddenly you have Wi-Fi all around you. So mobile devices can buy and sell bandwidth from one another, and that's a whole other thing that runs on top of the computing with integrity operating system and file system and all of that stuff. But that's a whole other thing. I mean, that runs on top of Bridgeport. So Sigma runs on top of CWI, computing with integrity, and computing with integrity runs on top of Bridgeport, and Bridgeport runs on top of Bitcoin, and Bitcoin hopefully works, maybe, sometimes. And if it does, then maybe Bridgeport can work, and then maybe CWI can work, and then maybe Sigma can work, and then maybe I can be satisfied and stop building things and go shoot potato guns all day, because that would be kind of fun also. But until then, I've got to make Bitcoin and Bridgeport and CWI and Sigma work, including all the other technologies that are required, such as the distributed content storage thing called NanoStore and some other things like that. But I think NanoStore works pretty well. It relies on Bridgeport, but that's a whole other thing anyways. So I think that the operating system stuff is fun, and I want to build some custom hardware because Qualcomm and whoever else, in fact, I probably shouldn't go into too much detail because it's a public forum again, but people don't like it when you mess around with cellular modems because it's all proprietary technology, and you're not supposed to mess with proprietary technology and reverse engineer the binaries and things. So I'm going to build a custom device at some point in the future. That could be fun. Custom.
You're mostly using
Bitcoin smartphone.
testnet.
What is it?
Are you using testnet mostly?
No, I
Like you're
use
running on
mainnet for
testnet.
testing.
Or using, yeah, I do. Well,
I should use
have
testnet.
fun with the big 2 gig block if you run into it. I give even the block number. We'll
I mean,
see.
it might be.
I don't know. There's several dimensions to this whole picture, but I'm disappointed. I think they've really messed up.
Yeah,
I think they've really messed things up.
I don't know. It'll be fun
mean,
to see
either-
what
yeah.
happens.
I mean, indexers. Are you using when you okay? If you don't use a full node, you use a prune node. So didn't you use Unwriter's indexer? He didn't. He maintains an indexer. You use
Yeah, I mean,
that
if
to
his
get
stuff
to the
goes down,
transactions?
I have contingencies if his stuff goes down. But either way, I mean, like my stuff runs fine. I haven't had any issues because I think Unwriter has kept his stuff in pretty good order. But if his stuff goes down, if he wants to work with me, I would really like to pay for, because I use his services a lot. And so if he wants to make some money,
So you
then
get a transaction. You can get one transaction from this thing from an indexer. Is that what you do?
I could, but most of them are submitted directly to me. So like the sCryptStudio thing.
Yeah. So right now, as I said, you're capturing what you submit. You don't even go back to old blocks at all at the moment. I mean, just
Well, I
see
do.
current
So once I
development.
submit it, I get the block from Bitbus, or I get the response, the Merkle proof from Mappy. And either way, I know the position of that transaction in the chain, and so I can then roll back and put it in and then roll forward. And that actually happens. Like every 10 minutes, a block comes in, and I roll back the unconfirmed ones, and then I put the confirmed ones in the right order, and then I roll forward the rest of the unconfirmed ones that weren't just confirmed. And so it does process blocks like that.
Oh,
and
so
I
it's
get those blocks
Bitbus.
from, what is it?
Using Bitbus
Using Bitbus,
to get a block.
right? And so I have
That's what you're doing.
I have a contingency in case Bitbus goes down, which I'm working on, and I think that it's going to work very well. And so,
Okay, well then, right, this it's block 705,636. I like to see how Bitbus can, I guess I should try if it can get block 705,636. 705,636 is a 1.8 gigabyte or maybe 1.18. I think it's 1.8.
I have
actually.
715,229.
So 705. So for 705,636, I think it is.
I mean, Bitbus let me know about that block. It
What does it say?
What does it say? Well, I mean, all of the transactions inside that block would have been incorporated into my into the Bridgeport state machines that I run, but I know that's a very large. I presume I haven't checked that particular block, but let me go and you said so
705,636. I'm trying to get
block
it
number
here.
700.
Yeah, 1.8. Yes, 1.8 gigs. Yeah. 705,636.
I go to what's on chain, block 705,636, size, yeah, 1.811754,
Yes.
100
Yeah.
gigabytes.
So I
So
wonder, yeah, if
fairly big, but also, that's just kind of, I mean, if I can't process it on my Bridgeport node, somebody else probably can. And if nobody can, then probably the miners are not going to want to process it either, so it'll get orphaned, and then they'll mine a smaller block, like you said, right? If I, as a miner, create a block that's so exorbitantly large that not even the other miners can process it, first off, it'll probably piss some people off, and they'll probably, not like that miner. But secondly, the miners would probably orphan the block, and so the miner who made the large block would lose money because they created a block that is too large. So
Like when I do get blockchain info, I'm stuck on that for several
right.
hours.
I mean, you're running
Like
you're running. I think what's happening is either you're running a node that isn't on optimized hardware, or the
no, I am
software
optimized
is,
hardware. Yeah.
or the software is having an issue or something like that. But either way, I mean,
Software's got issue.
there's going to be people who aren't able to run nodes, and so therefore they either in that case, I mean, if it's very important that a node continues to run, what a person should probably do is either pay somebody to fix the software, or and if they don't have the money to pay somebody to fix the software, then economically speaking, I mean, it might not be necessary to run a node. I mean, just like most people don't have to run a BGP router because economically it's not necessary for them to. Maybe they could benefit from it, but they can't pay for it. So it's kind of like the market is telling you, it's tough, right? gotta get some revenue so that we can afford to run the darn thing, right? And so that's kind of what I see happening there. But I think also there is some there is some need to have things continue to run, and so we'll see how things play out over time. I mean, maybe my Bridgeport state machines keep running. Maybe the 9 of them that I've built so far are not going to work in the future. But right now they work, and my users can make accounts on Babbage Desktop, and they can host their content on NanoStore, and they can create contracts in sCryptStudio. And so I'm pretty happy. And if those things continue to be true in the future, then, that would be good. Right now that depends in part on things like Unwriter tools, but I have a very strong interest in making sure that my users of Babbage Desktop can continue to use Babbage Desktop. And because all of the Babbage apps are going to rely on Babbage Desktop. And that's a very big part of, or Babbage Mobile or whatever, so the point is, if I can keep it running, then I get to stay in business. And if I can't, if there is no possible way to arrive at the correct state of the blockchain based on the protocols that I've written and based on the size of the blockchain or whatever, if that is completely impossible, and if I as a programmer cannot find a way to write code that does that to keep my users and my services running, then maybe this isn't the industry that I should be in. But I have a feeling that it will work out. We'll have to see how things work in the long term. That's kind of a.
They gave that new Java library that will solve this. But
are you talking about Nakasendo or something?
No, it's the the recent one. I've got a
Kensai
browser pages.
No,
Kensai? This is way after. More recent. Those are old already. No, it's no. It's the one that they. I've got it right here somewhere. Java. Oh, I know where it is. Somewhere sCrypt. I think it's right here. BSD Java component JCL 1.0.5. It's called the JCL.
I don't know. I mean, I haven't messed with any.
Bitcoin
JSP. Those things.
Yeah, well, that's the one. That's supposed to solve. It can go and get transactions.
Well, who said that? Who said that was supposed to solve that?
Shatters.
Oh, well.
I talked to him. No, this is the thing. He announced it. It's the thing we're supposed to start using, but nobody's implemented or hosted it. So I mean, you can't do it today.
I don't want to say I'm not gonna. I have
JCL.
a lot of respect I have a lot of respect for those people. I recommend that you would, you know, I would talk to them about it if they're the one that provided that software for you, and go from there. But I know my software. I don't know their software, and I haven't messed with it.
It's
any of
Light
it, so-
Client. Okay, it's called Light Client Toolbox. The Bitcoin SV Light Client Toolbox
Hmm.
from Unchain. I mean, it's on the Bitcoin SVIO.
Yeah.
They just announced it. So they announced Light Client Toolbox, Light Client, LITE
Hmm.
client.
Yeah.
So that's what they have.
Um,
Light Client. That thing's supposed to, you don't need a full node. You just go ask this thing
Mhm.
For, you know, transactions. It can go get them for you. But the thing, who's the hell's going to host it? Yeah, okay. So that we will have a solution.
Mhm.
Just don't know when. Yeah.
all right. Well, I'm going to
Okay.
drop out of
So
this.
interesting. Yeah. Thanks. I'll keep your thing in mind that you could write to your spec for
Yeah.
longevity kind of reasons. Okay,
Hopefully it works in the
thanks.
long term. I think
Interesting.
it will. I think it's the only way that it
Yeah, I
can
know.
work.
I think it'll work. Yeah.
So,
It's just the implementation.
yeah.
Okay,
We'll
the
get those
spec is great.
nuts and bolts figured out and stuff. All
Yeah,
right. Well, I
thank you.
will. I'll be
Okay,
on next
thank you.
week, and I'll talk to you guys then.
Yeah. Bye.
All right. Bye.
Nice hosting.